Hi, and welcome to a review of two things on this short video. Will be, first of all, a review of what complex numbers are, imaginary numbers and real numbers, how to multiply them together. And then second of all will be a review of solving using the quadratic formula over real numbers and over complex numbers. Okay, so let's first talk about what complex numbers are. So this is a nice little chart that shows complex numbers are pretty much every number that include the imaginary numbers. So a plus bi is the standard form for a complex number. A would be considered the real part. B would be considered the complex part, or the imaginary part. Okay, so if you have b equals 0, then you're looking at your real numbers, right? Because there is no imaginary unit. And then if b does not equal 0, then you have your imaginary numbers. And imaginary numbers can be pure imaginary, where there is no a part, it's just the imaginary part, or it can be just an imaginary number where there's an a and a bi. Okay, so those are also complex numbers. When you have a plus bi, that's a complex number. When they're both there, it's still a complex number. Okay, so and of course real numbers are divided up into two subgroups as well. You've got your rational real numbers and your irrational, the ones that can be written as fractions and the ones that can't. Okay, so complex numbers are of the form a plus bi, where a is the real part, so that's a is the real part, and the b is the imaginary part. Okay? Alright, so between this little bit here and the chart, that's hopefully a refresher on what complex numbers are. All right, now what's important about, well, what is this I anyway? So the I, remember, I is equal to the square root of -1. That's the definition of I. And so it follows from that if you square I, you get the square root of something squared just brings out whatever's on the inside. So the I squared is -1. Okay, this is going to be important for when we multiply these together. So let's look now at an example of multiplying what's called complex conjugates with each other. X minus 2i times x plus 2i. That's called a complex conjugate. So we would FOIL this just like normal. So we get first times first is x squared. Outer times outer is plus 2xi. Inner times inner is minus 2xi. And last times last would be minus 4i squared. But remember, I squared is -1. So we're actually going to lose all of our imaginary parts in this product. These two, because they're the same and they cancel out, right? Plus 2xi and minus 2xi just cancels out. And this one, because it's -4 times -1, right? Because I squared is -1. So you get x squared minus 4 times -1, which is x squared plus 4. There it is. Now the beauty of this, again, is that you can multiply things that have imaginary units, but your product doesn't have to have the imaginary unit. And in fact, anytime you multiply a number by its conjugate, you lose the imaginary units. And this is actually almost the same thing happening here. And so let's multiply these 3 by 3s. Now this is distributive property 3 times. And when it gets a little bit more complicated like this, some people like to make a little table. So you can make a little table, because there's going to be 9 different pieces. If you think about it, this 2 by 2 had 4 pieces. Well, a 3 by 3 will have 9 pieces. So what I'm going to do is I'm going to put the a square for each of the products. On the top, I'll put the first one, x minus 4 minus 3i. So x minus 4 minus 3i. And on the side, I'm going to put these. So x minus 4 plus 3i. And let's see what happens when we multiply, just like a multiplication table. X times x is x squared. X times -4, -4x. X times -3i is -3xi. Again, this is just a way of organizing. You don't need to make the table. It's just a way of keeping track so you don't lose any terms. -4 times x is -4x. -4 times -4 is 16. -4 times -3i is plus 12i. Okay, 3i times x is plus 3xi. 3i times negative 4 is minus 12i. And 3i times negative 3i is negative 9i squared. Negative 9i squared is going to be negative 9 times negative 1. And that's going to turn into a real number, not an imaginary number. So let's see what we get. We get any cancellations here? Well, we get the plus 3xi minus 3xi cancel. Plus 12i and minus 12i cancel. And then these are like terms, right? Because this is a 16 and this is just minus negative 9 times negative 1 is plus 9. So these add up to 25. And these are like terms. They add up to negative 4x. So what we get here for our product, x squared minus 8x and then plus 25. All right, now let's go ahead and use the quadratic formula. Quadratic formula, let me just write it here. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Hopefully that looks familiar, and we're looking at this. We're looking at a equals 1, b equals 4, and c equals 2. Now, let's see what we get when we plug this in. So x equals the opposite of b, so that's negative 4 plus or minus the square root of b squared, that's 4 squared, minus 4a, which is 1, times c, which is 2, all over 2a is 2 times 1. All right, inside the radical you get 16 minus 8, that's 8. So we have negative 4 plus or minus the square root of 8 over 2. We can break these both up. This can be simplified, so this would be negative 4 over 2 plus or minus, this is 2 rad 2 over 2. 2 rad 2 over 2. And this reduces to negative 2. And this reduces to plus or minus, the 2's cancel, so plus or minus rad 2. Okay, let's do one. Now that's over real numbers, and those are both real numbers. They're irrational, but they're real. So they fall under this category right here. Irrational, but they are real numbers. There's no imaginary part. Now let's look at this example number 4, and let's apply the quadratic formula again. So this time we have a is 1, b is 4, and c is 8. So we have x equals negative b, so negative 4, plus or minus the square root of b squared, which is 4 squared minus 4 times a times c, all over 2 times a. All right, this time inside the radical we have 16 minus 32. That's a negative 16. So this becomes negative 4 plus or minus the square root of negative 16 over 2. Negative 16, we want to break that up. That's the square root of negative 1 times the square root of 16. So I'm going to rewrite this. Negative 4 plus or minus the square root of negative 1 times the square root of 16 all over 2. That's I. That's 4. So this becomes negative 4 plus or minus 4i over 2, which becomes negative 4 over 2 plus or minus 4i over 2, and that simplifies to negative 2 plus or minus 2i. Okay, let's try these on the bottom. So let's try this one first. You're going to get real zeros here. So I'm going to pause it and I'll just show you the answer. So let's see if you can get that too. Okay, so did you get 5 over 3 and 3 over 2? Hopefully yes. That means, by the way, notice that these are both rational. What that means is that you didn't really need the quadratic formula. It means that this whole thing was factorable. We could have factored it. Sometimes you look at it and you think, can I factor it? You're not sure. Go ahead and use the quadratic formula and you realize, oh, my answers are rational. I could have factored. Sometimes you get the irrational numbers and you're like, yeah, there's no way. I could have kept searching and searching for a way to factor, and with that radical, that tells me that there was no way of factoring. Just a little pointer there. That's why sometimes we just fall back on the quadratic formula instead of trying to figure out another way to do it. Okay, let's try this one. We're looking for all complex zeros. A little hint here. This is not, this is a typo. That's the hint. This is supposed to be squared. Let's make that squared. And you can use it using quadratic formula or any other method that you see. Okay, so I didn't use a quadratic formula because I recognize that this is something I can just do by subtracting and taking the square root of both sides. But when I take the square root of a negative number, I get plus or minus a negative, factor out that negative 1, which is really just an I right there, and then I get plus or minus I times the square root of 8. Square root of 8 is 2 rad 2, plus or minus 2 rad 2I. I like to write the imaginary, the I after, so I know that I have this much imaginary units. Okay, so plus or minus, that's the two solutions. Now, a little, so something I would like you to notice about the directions here is that in the first set of directions for 3 and 4, the directions set to solve over real numbers, and you have an equation. This is just an equation, and these are the solutions to the equation. Here, these are the complex solutions. These are also complex solutions, but because b is 0, there is no imaginary unit, they're also real solutions. So in other words, going back up here, when I ask you for complex solutions, that includes the real solutions. So that includes the case where b equals 0. They're still considered complex numbers. In other words, every number that you knew before you knew what a complex number was, before you knew about I, every number that you knew before that was still a complex number. You just didn't have the imaginary part of those complex numbers. So this is an enlargement of the number set rather than a replacement or going to a different set of numbers completely. Complex numbers include real numbers, and they include non-real numbers. They include rational, irrational, and pure imaginary, and just imaginary, which might include like a 4 plus 3i, for example. Okay, so on the bottom part here, when we're looking for finding the real zeros, we assume that we're setting this equal to 0, and that's pretty much, I just assumed that, I just glanced right over it, okay, but that's what we did. By setting this equal to 0, that's when you use the quadratic formula. So we found the 0, and this time I actually wrote it in equal to 0 because it's easier to see what we're doing when we're taking the square root of both sides. Okay, hope you found this review helpful.